This is your review on graphing basic exponential functions. So a basic exponential functions has a base and just the exponent x. And the question is, how would I graph that and how would I analyze it? That's what the quiz is on too. See how blurry it is? All right, so for a basic exponential, a point that's on every one of them is the point 0, 1. And the second point, I need to recognize if the base is bigger than 1 or smaller than 1. So this base is positive 3, as I try to focus this in. And so because of that, I use positive 1 and what the base is. We're going to do an example where the base is smaller than 1. We use negative 1 and the reciprocal of the base. And then last, the asymptote, which gives us the end behavior, one of the ends, is always y equals 0. So when I graph this, I start with the point 0, 1, and then the point 1 and 3, and put those on my graph. And then the asymptote will be over 0. Again, an asymptote is twofold. It can tell you what is undefined as well as the end behavior. And then this is going to curve up to the right, and then it's going to follow the asymptote to the left. So there's the curve of an exponential. The domain of every exponential is all numbers, all real numbers. So we write it from all numbers from negative infinity to infinity. The range comes from the asymptote. That's at 0, and it goes 0 to infinity. The end behavior, as x approaches infinity, the right side goes to infinity. The left end behavior, as x approaches 0, the function approaches, as x approaches negative infinity, y approaches 0. So the left, this is the right, and this is the left. So the right end is going to infinity, the left end is going to 0. And then if you're asked for the y-intercept, that's at positive 1. If you're asked for the asymptote, we already wrote that down. That's at y equals 0. All right, let's do one more example together. What would happen if it wasn't a growth function? If it was a number less than 1, so it would be decay, what would that look like? So y equals 1/4 to the x. How would I graph that? So again, we would start with 0, 1. So no matter the basic exponential, it is always anchored through the point 0, 1. Then, because the base is less than 1, we're not going to use positive 1. Instead, we're going to use negative 1. And what negative 1 does is does the reciprocal. So the reciprocal of 1 over 4 is 4. And those are the 2 points we put on the graph. And the asymptote stays at y equals 0. So we're going to plot those 2 points. Hopefully my camera stays focused. So negative 1 and 4, and then I'm going to graph that. Oh, and the asymptote at 0. So the left end goes up forever and the right end here goes. So notice how this is decay. The domain doesn't change. It's all real numbers. The range does not change. It's still 0 to infinity. What does change is the end behavior. So the right end now is going to 0, and the left end is approaching infinity. So this right end is approaching 0, the left end is going to infinity. The y-intercept stayed the same, and the asymptote stayed the same. And there it is. All right, Mr. G Math over and out. Good luck on the quiz. I hope this review helped. Until next time.